Alright, so the day has come. Today, you guys will be learning the last chapter in engineering mechanics under the topic of dynamics. So, this is the last one. So, the last topic will be touching on the topic of kinetics of a rigid body. So, under F is equal to ma. So, previously we've done something called kinetics, but it is kinetics of particles. So when you're looking at particles, you have very small thing. So you are learning something called, probably this one, summation of force is equal to ma, but on particles. You have forces going up and down, slanting probably. However, you cannot apply this equation. You cannot apply moment equation. Why? There is no distance over here. So now we are dealing with something called rigid bodies. So for rigid bodies, you're going to have proper dimensions. There'll probably be dimensions, distances, and you're going to be dealing with moments. So if you look in front here, these are all proper rigid bodies. So rigid bodies. So these are all rigid bodies. So most likely you're going to be dealing with rigid bodies all in your life, all in your careers. And if that rigid body is moving, that is the analysis that you'll be doing when you're dealing with these things. When you're designing new things, you're going to be dealing pretty much a lot more with rigid bodies. Not so much on particles. So these are particles, these are rigid body. So this is the best that you're going to get now for dynamics, and this is the most realistic portion when you're analyzing dynamics. Okay, so under kinetics of rigid body, we have been introduced with these equations, which is summation of forces is equal to m times a. So force and mass and acceleration. And you've got all sorts lah. You've got x and y and z. You've got acceleration x, acceleration y, and acceleration z. So basically, you've got probably three. So you've got motion in terms of rectilinear translation, and there is curvilinear translation. We will learn one more later on rotation. Rotation, probably on a fixed axis. We are supposed to be learning something on general plane. However, this one, a computational analysis is more easier, but you can learn also something on general plane. So general plane is rotation plus translation. Rotation on fixed axis is just rotation lah on fixed axis. Okay, so let's look at rectilinear translation. It's basically linear translation. So from this part of the thing, probably I should draw a body. It translates in this direction. So just linear. For curvilinear, it moves on a curvilinear state. Something like this. Curves a bit. So let's look at the equations. You're pretty familiar with this one. Summation of force in the x direction is equal to mass times acceleration in the x direction. So when you're looking at G, G stands for the center of gravity or the centroid. So when you're looking at summation Fy, you've got summation Fy is equal to ma at the center of gravity times y. So G is the acceleration at the center of gravity. So if your body is quite big, you should not analyze acceleration here or here. Although when you're traveling linearly, it's about the same. But when it's rotating or some sort or curvilinear translation, probably it's going to be slightly different. So always analyze at G, which is your center of gravity. Yeah, center of gravity. So when you're looking at moments, moment is something that tends to rotate. Moment. If you are using this one, this is linear translation, right? Nothing is rotating. So when nothing is rotating, summation of moment equals 0. If you have some things rotating or rotating in a straight line, you're going to have moment lah. You're going to be able to use this formula. This formula is valid if it's rotating. What is it doing? Rotating. This is for something rotating. However, if it's not rotating, it's just a pure linear translation from one location to another location, from A to A. So this one, no. Summation of moment is equal to 0. So, yeah. It is the same thing when you're looking at curvilinear translation also. There is no pure rotation. However, when you're looking at curvilinear translation, you need to be looking at summation of force normal is equivalent to m times a normal. So curvilinear. So you've got, this is the object. So the thing that you're looking at is this one. You've got a tangential and you've got a normal. So these are the two parts lah. So since it does not really rotate purely, yeah, summation of moment is equal to 0. So when do we use this equation? When things are rotating, you have to use this equation. Use this when things are rotating. So O stands for, I suppose, at the location that you are analyzing. So basically, you got to look at this one. You got to, this one is rotating at the axis of rotation. This one is at the center of gravity. So what are the difference between these two equations? When you have objects which is purely translating from here to this one lah, it translates. So you have summation of force is equal to mass times acceleration. This is called mass times acceleration. So this is force lah. So when you are looking at this one, this is for something rotating. What is rotating? Let's say you have a disk. This is a disk. In order for this disk to rotate, you got to give it a moment. So this disk is a representation. It could probably be a wheel or a tire, or it could be a fan. It could be a turbine. How do you rotate all these things? You cannot give a force, right? If you give a force, what kind of force are we talking about? Can you give a force and make it rotate? No, it will not rotate. Can you give a force here and make it rotate? Nah, it won't rotate. It will translate. You cannot give it a force. So what you do is you gotta give it a moment. This is what this equation is all about. You give a moment, and that moment will be equivalent to moment inertia times alpha. So alpha is your angular acceleration. It's almost the same as this one, only this one is linear acceleration. Now you have angular acceleration. You have mass over here. You have moment inertia over here. So if the object is heavy, you need a bigger force to push, right? Mass. If the object is having higher moment of inertia, you need a bigger moment in order to rotate. So we'll be looking at this more in the next part of this lecture. So I might as well go now. So this is what happens when you have rotation about a fixed axis. So when a rigid body rotates about a fixed axis, the body center of acceleration of point G can be represented by this one lah, tangential part and normal part. We'll go through this more detail in the second part. But since you guys are here, we might as well define this and understand this. We have been dealing with mass. We have been dealing this with all our lives. Currently, we have something called moment of inertia. So moment of inertia is also can be known as angular mass. So it's no longer linear. You're trying to give a force in order for it to translate. You are basically trying to rotate things. So no longer a force, you are actually giving it a moment. So you can call it either moment of inertia I or angular mass. So moment of inertia, it's more engineering in terms that you're giving it a moment. However, angular mass is something more commonly easy to understand. Probably this one easier to understand. Or something called rotational inertia. So let's look at this thing. What is this thing? This big, huge thing. So this is something called a flywheel. So flywheels are very, very, very big and heavy. This is heavy stuff. So this is very heavy, and one of the purpose of your having flywheels is to smooth out any mechanical motion. So how to explain this? If you so look at this. If this thing is very heavy, let's say this thing is a very big flywheel. It's rotating about here, this shaft, and there is a motor rotating this thing. This thing is a motor. Definitely you need to hang this on bearings. So when this is a motor, this is a flywheel. So when motor rotates, flywheel also rotates. So if your flywheel is big compared to a small flywheel, this is a small flywheel connected to another motor, similar motor. Definitely this is big and this is heavier. Not heavier linearly, heavier angularly. So meaning it's harder to rotate. So it has higher angular mass. Higher angular mass. So it's harder to rotate. This one is lighter lah. Lighter angular mass. Ataupun dia punya I lower. Ini I higher. So since it's heavier, it rotates, it takes a long time to get to actual speed. This one will help. For example, the motor is cut off. If you cut off the motor, the rotation of the shaft will not die off so easily. So the fluctuation of power or angular motion is more stable. However, in the bottom case, since the flywheel is very light, so it stops easily. Stops easily. So your flywheel power output probably will fluctuate if you are having cut off of the motor. So probably this is something very new for you guys. Too bad you guys are learning this when you are, how old are you guys? 21 years old? 20? So there is something called moment of inertia. So when you're talking about moment of inertia, you tend to misunderstood. Misunderstood. Probably angular mass is more suited for the definition. But yeah, you're going to be looking at this a lot more time. So this is something called I. And the typical unit is, kalau summation of force is equal to MA, summation of moment ni, I ni, this I, right? Summation, okay, this is summation of force. This is summation of moment is equal to I. Alpha is actually MR squared. Macam ni nampak senang sikit. MR squared. But alright, so now we are at equations of motion about a fixed axis. Might have to delete a few things. Keep in annotation. Okay. I'm gonna have to delete a few things. Okay. So this was it. So far we've been learning on motion in a linear format. Linear. This is also linear. This is also linear. And some curvy linear. But now we are going to study about motion in a fixed axis. Why do we have to study this one? Yeah, we need to know. Let's say this is a lorry. This lorry is actually carrying the cement mixer on the truck bed. So this is a cement mixer truck. It's huge, this cement mixer. And this cement mixer is very heavy, and you need to rotate this cement mixer all the time. Slowly or fast, this lorry needs to be rotated so that the cement does not dry up. So how do you determine what is the motor? Where do you put the motor? Here. So let's say you are designing this motor. This motor is coupled to the cement mixer. So how much power do you need to give the motor? What kind of torque are you looking at on this cement mixer? So you need to analyze and study something called summation of moment is equal to I alpha. What is the moment to rotate this angular mass, right? And this is your angular acceleration. Angular acceleration. So these are the things lah. Simple more things. Fans. If you go to certain mosque, they have this huge fan. Huge fans. And this fan is coupled directly to a motor. Yeah, this is the fan. This is the motor. So what do you do? So you need to know what kind of moment or torque the motor specs in order to rotate this fan. So this is what we are learning right now. Okay, so something called equation of motion with rotation about fixed axis. So let's read. We don't do a lot of reading here. So when a rigid body rotates about a fixed axis, the body's center of acceleration at point G can be represented by a tangential component and a normal component. Okay, so this is the equation lah. Normal acceleration is equal to omega squared r, and tangential component is equivalent to alpha. Why is this like this? It comes from here. V is equal to this one. I think we've derived this before. S is equal to r theta. V is equal to r omega. A is equal to r alpha. All these other things. Next is this one. Summation of moment is equal to I alpha. So this is one important thing that we need to note also, which is when the rotation is not at the centroid or center of gravity, we need to use something called parallel axis theorem to transfer the angular mass or mass moment of inertia. So what am I talking about? Let's imagine this one. Let's imagine that you have a pin joint. This is a pin joint. On this pin joint, you have a rod. This is your rod. What is the dimension of the rod? The dimension of the rod is, let's say, 2 meter. So if you're trying to rotate something like this, you're trying to give it a moment. Is it very hard? What kind of moment should you give to rotate this one? Let's say this moment is MA. Now, look at the second case. Second case is, I have the same pin joint, but now my beam is the same length, 2 meter. There you go, 2 meter. Now, where is my moment? In order to rotate this one, I want to rotate it that way. So, let's say I change this one. This one I want to rotate it this way. This one also I want to rotate it this way. What kind of effort should I put on into moment B? Is it worse or easier? Right, I have the same thing. This thing is called beam. This thing is called beam also. So both are beams. Both are same dimension. Both are having the same weight. This one mg is at the center, at here. This one mg is at the center of rotation. So in this case, although the object at center of gravity does have the same I, which is moment inertia, now it has shifted by how much? Shifted by this much. So something like this, you cannot analyze at IG anymore. You have to analyze at I0 or IO, at the center of rotation. So something like this, you have to use something called parallel axis theorem. So you need to take IG plus, I think it's md squared. This is the formula. This is the moment inertia at center of gravity. This is mass. This is IG lah, center of gravity. This is the distance that it moved. Distance. How much does it move from the origin? So it moved by this much lah. It moved by this much. 1 meter. So you gotta tackle this one, parallel axis theorem. So this is the formula that I'm talking about, which is you need to find this part. If the rotation is already at center of gravity, just use lah. If not, just put one more lah, which is parallel axis theorem. And we have discussed this. Moment is equal to, okay, this has to be this one, summation of moment is equal to I alpha. Okay, when you're talking about alpha, the direction of it rotating is positive. Kalau dia putar macam ni, ini positif. Kalau it rotates if it rotates clockwise is positive. The direction of moment is your positive. This works for all dynamics. It's easier to analyze this way. This is the thing. M is the mass of the body. D is the perpendicular distance. M is mass of the body. D is the perpendicular distance between parallel Z and Z. Okay. The distance it moved. Okay. Before we tackle radius of gyration, we need to look at a couple of properties first. These are the properties. If you have a solid cylinder, this is a solid cylinder. Let me take out a different color. This is for a solid cylinder. The value, if the rotation is about this axis, meaning if you're looking from the side, it's like this lah. If you rotate this thing along this axis, the moment is like this. Okay, and the I is equivalent to this one, half mass times radius. This is your radius lah, R. Yeah, this works for some sort of cylinder. If it rotates this way, kalau dia rotate macam ni, like this one, the rotation has changed. How does it change? Same cylinder, but now you are actually rotating it like this. The moment is like this. Then it's different story already. It's harder to rotate. So for this part, you gotta take this one. Do you have to memorize this? No, no need to memorize. All these tables will be given to you. What are other things? What are other things? Let's take a look at this one. Hoop about symmetry axis. I suppose this one you can use for the cement, lorry cement. Hoop about symmetry axis. You can use this for a bicycle wheel probably. Bicycle wheel, solid sphere, this one when you want to rotate planet Earth, rotate planet Earth, this one lah, sphere. And this is when you have a rod about center, and this is when you have a rod about the end. So pay attention to these two things. Let me add something up. Okay. So rod about center is 1/12 ml squared. Okay, so let's do this. If you have a rod and you are rotating it at the center like that, so center of gravity is here, right? This is your G, CG. I is equal to, what is it? Look at this again, 1/12 ml squared. 1/12 ml squared. This is if it's rotating there. But if it's rotating here, this one, this was the axis. Now this is the axis. What is this length? The length is definitely L. This is L. So this is definitely the formula, 1/12 ml squared. So what happens when you shift? Where and how long did you shift? You shifted the axis of rotation to this direction. The length now becomes L/2. This is still L. Okay. you shifted by L over 2. This is your D. So when this one has been shifted to here, O, so you need to follow the parallel axis theorem, which is I naught is equal to IG. This is IG lah. Plus MD squared. This is parallel axis theorem. So new value is IG. Berapa? 1 over 12 ml squared. Distance M. D. So this one becomes L over 2 squared. Correct ah? So what happens now? 1 over 12 ml squared plus ml squared over 4. So berapa? Do it on the side. 1 over 12 plus 1 over 4. What happens now? Ini multiply by 3, ini multiply by 3. So dapat 12. So ini dapat 3, 3 jumpa 1, 4. 4 over 12. 4 over 12 is what? It's actually 1 over 3. So the answer 1 over 3. So the answer would be 1 over 3 ml squared. This is the new value for angular mass or angular moment of inertia. This is the new one. New. Is it correct? Go up. There you go. This is correct. That is how you use parallel axis theorem. Okay. So let's do an example. What kind of example? So this thing is still valid lah. This thing is still valid. It's actually quite good, no? You've got all your formula here: linear and rotational motion, xva. S is equal to vt, yeah, correct. Mass F is equal to ma. Momentum is equal to mv. Work is equal to fd. Power is equal to mv. This one, torque, work is torque theta. Power is torque omega. So everything works lah. Everything is still valid. Okay, everything is still valid. You can still use. This formula is a good one. So you gotta believe it. You've learned all this. Learned. Alright. One thing I haven't taught you guys on something called radius of gyration. So radius of gyration. So occasionally the moment of inertia of a body about a specified axis is reported using something called radius of gyration k. So radius of gyration k je lah. What is it? How to convert? So you have to convert to get the moment inertia. Why? Why is this like this? So we're gonna jump through and look at an example later on. Yeah. I'll wait until we go to this example and I'm gonna explain to you guys. We'll do simple ones first. We'll get back to that one. So, how to calculate moment of inertia? This looks like a plate or a disc. Yeah, it's a disc. Thickness is 10 mm. So in order to find this, you can get the whole and minus the inner whole. Does this make sense? So typically what happens when you get a disk? You got to look at tables like this. Is there something about a disk here? Apparently not, huh? I don't have a value about a disk. This one, slightly complicated, huh? Okay, so you got to use density to get the mass, and then this one is about O, and then you got this one is for the disk, which is this one, 1473, and this one is for the whole, which is 0. This is 1.473. This one is 0.276. Okay, so yeah, and this one is for the total lah. This one you have to minus. This one is minus. So why is it so complicated? It's complicated because the axis of rotation is not at the center of gravity anymore. For a disk, you can Google it up. Disk, D-I-S-C. I at center of gravity is equal to mr squared, and that's it. Oh no, half mr squared. Half mr squared. I don't have it in a table here. Yeah, this one, solid cylinder or disk symmetric axis. Okay, so this is the thing lah, half mr squared. Okay, so half mr squared. But you need to put something called parallel axis theorem. Why? Because your axis of rotation is at O. You got to do that. Okay, since this one is rotating at O. If it's rotating at G, it's a straightforward case lah. Just take this one. Ini, and then minus this one. And then you're good to go. Okay. But typically, normally it's given. Why is it given? Because normally you are going to be dealing with very funny shapes. Something like this. What is this? It's a 100-kilogram wheel. It's huge. And it has a very weird shape. The shape is very weird. Okay. How are you going to calculate this one? For example, sport rim. What does a sport rim look like? Probably something like this. My God, the best sport rim ever. Let's draw a sport rim. Sport rim wheel. Sport wheel rim. There you go, the best looking sport rim ever. So this sport rim is weird looking. It has hollow things. It has a weird shape. It has very cosmetically pleasing to the buyer for this sport rim. So there's no way you can calculate manually and make it accurate on this ini. Kalau dia rotate kat sini kan, what is moment inertia for this sport rim? Very hard to do. Very hard to do. So something like this, Typically, we can calculate it by using experiments, or you can deduce it from your cat. So for this shape, we will be using something called radius of gyration. So typically, radius of gyration we note at by O. No, by O, KO. KO ni rotation dekat O ni lah. So the unit is meter or millimeter or whatever they give you. In this case, 500 mm. This is for this rim. It is shape dependent. Shape dependent. Meaning, if they give, if the radius of gyration is 500 mm, let's say you are using aluminium alloy. Aluminium, you can get this wheel to become slightly less weight, lighter. Maybe if it's in aluminium, it's probably 30 kilo. If it's cast iron, what should I write here? Cast iron. If it's cast iron, it's probably at this weight lah, 100 kilogram. So both of them will have different weight. Ini berat lain kan? Ini pun berat lain. But both of them share the same K. Same radius of gyration, which is 500 mm. So later on, let's say the engineer wants to improve the design. He has changed the shape of the wheel using a different material, probably, I don't know, carbon fiber ke? The weight now becomes 5 kilo. Very lightweight. Still same. K naught is still 500 mm. So radius of gyration of an object is shape dependent. Different weight. Different weight is okay. So when you get something like this, it's easier to convert. You just have to use the formula for this one. Look at this formula. Formula for radius of gyration. Ig is equal to m kg squared. Ig, this is the formula. Ig is equal to m k squared. Is this correct? Yes, it's correct. So, masukkan je value. Kalau aluminium berapa? 30 kilo lah. Kali dengan 0.5 squared. Dapat value. This is for aluminium. Kalau cast iron, you gotta plug in 100 lah. Berapa? That's the thing lah. So the unit is kilogram meter squared. Kilogram meter squared. This one I never told you guys. Moment of inertia. The unit is kilogram meter squared. So that's the thing with radius of gyration. Now, we haven't done anything, Let's do something. I guess you guys have to write down lah in your notebook. You're gonna write down all this. We have to clear this thing up. I can use this one only, right? clear erase all ink on the screen. Alright, first things first. I is equal to mk squared. Mass 100 kilo. Radius of gyration 0.5 squared. Dapat jawapan. What is the jawapan? 0.5 squared times 100. 25. Moment inertia is 25 kilogram meter squared. This is your I. Okay. The radius here is 0.6 meter. This is the radius, eh? So the radius to here lah. Same lah. 0.6 meter. If the wheel starts from rest, determine its angular velocity in time is equal to 3 seconds. There you go. Can you do it? What is the formula for you to do it? Summation of moment is equal to I alpha. The formula is very simple. This is the formula that you should plug in and use. So this thing will rotate this way, right? So this direction is positive. It's quite simple. So moment 100 kali 0.6 due to the radius. Is there anything else? I don't see anything else. I berapa? 25 alpha. So alpha you're gonna get 100 times 0.6 divided by 25. 2.4. 2.4 watt radian per second squared. This is the alpha. So it rotates from rest. P does not change. So P is constant. This acceleration is also constant. Okay. This one constant. Yeah, determine its angular velocity in t is equal to 3 seconds. Probably you can use this one. V is equal to V naught plus AT. Convert to angular, omega is equal to omega naught plus alpha time. Omega naught starts from rest 0. Alpha, it's actually 2.4 time 3 seconds. 2.4 times 3. You get 7.2. What is the unit? Radian per second, because this is angular velocity in 3 seconds. So that's how you do it. That is how you do it. So if you give a higher force, it's going to spin much faster. If you give a lower force, it's going to spin much lower. So it follows by this equation. Moment is equal to I alpha. Is there a point where this thing does not rotate at all? If the friction is greater, if you have friction, and this moment is going to be slightly reduced due to the frictional. So yeah, the answer is 7.2. You are correct. Answer is here also, but you got to understand it. So in this equation, it's using negative 25. I don't like this. Don't follow this method. It's easier and less confusing if you are using this method. Arah mana dia rotate, that is your positive. It's easier to handle. Okay. This one, we're going to clear it up a bit. Clear it up a bit. Yeah, okay. So this is the first exercise. What is it about? It's about, yeah, the important thing from here. Applying the radius of gyration. Radius of gyration. Next. This looks pretty similar. 75 kilogram. Man, this looks pretty similar. 250, 150 sama je. You can try this on your own. How about this one? The moment is 100 Newton meter. 20 kilogram. It slips as it rolls. Determine the angular acceleration of the wheel and the acceleration of the wheel center O. So this one, it has, you gotta read this one first, huh? Try it first on your own. What happens when you have kinetic friction? It slips as it rolls. This gotta mean something. Try this out. How about the rest of the equations? There are plenty more. So we're gonna be doing this, okay? We cannot skip. Let's do this one first. Is this so hard? I don't think so. This is very easy. But you gotta try it on your own, okay? This one you gotta pause the video and then do it on your own. Do it on your own. You gotta do this, okay? Let's do this. Do. What is the answer? Write down the answer, okay? So we'll do this. Pause the video. Okay, so this is the next question that we are going to be doing. This is a wheel. It has a radius of gyration of 300 mm. This is the mass, 20 kilo. When the wheel is subjected to a couple moment, it slips as it rolls. There's a big thing here, slipping. It slips. If it does not slip, it's a different story. Determine the angular acceleration of the wheel and the acceleration of the wheel center O. The coefficient of kinetic friction between the wheel and the plane is 0.5. Okay, so now what do we do? Important things. So it slips as it rolls. This is something that you have to address. Kalau dia tak slip, it's very easy. Now mind, let's do this first. So this is the moment. And the moment is 100 Newton meter. This is the radius. So you've got mg and you've got normal. This thing is rotating like this, right? So it's trying to kind of move that way. So you're going to have friction. So this is kinetic friction. So you can give it a name. Fk is equal to mu k times normal. This is the moment lah. Moment is 100 Newton meter. So let's look at our equation. What is normal? That is very easy. Summation Fy is equal to MAY. AY is 0. Summation Fy is equal to 0. So normal minus mg is equivalent to 0. So normal is equal to mg, which is in turn is equivalent to 20 kilo times 9.81. Sama dengan 20 by 9.81. 196.2. Okay, never mind. Leave it here first. What else have we got? We have something called radius of gyration. So let's settle radius of gyration first. I is equal to mk squared. M berapa? 20 kilo. Radius of gyration is actually 0.3 squared. What is the value? Kilogram meter squared. .8. This is the radius of gyration lah. So you've got two parts. Done. What else? Summation of moment is equal to I alpha. So you need to settle the summation of moment. This moment is actually 100 Newton meter and the location is at O. Okay. So since it's rotating this way, this is positive. Let's take this as positive. So 100, there is no multiply anymore because this is already in Newton meter. So what else? Mg, is it involved? No. Normal, is it involved? No. You only have this one. You only have friction, which is negative. Mu k times normal multiply by radius, which is 0.4. Is equivalent to 1.8 alpha. Okay? Is this okay? So let's solve this. 100 minus mu k. What is it? 0.5. It's already given here. Times normal. Normal we already solved, which is equivalent to this one. 196.2. 196.2. Mu k normal times 0.4 is equivalent to 1.8 alpha. So solve this one. 100 minus 0.5 times 196.2 times 0.4. 39.24. 39.24 equals 1.8 alpha. So alpha you're gonna get minus answer divide by 1.8. 33.75 or 33.76. This is your angular acceleration. What is it? Radian per second squared. So this is how you solve angular acceleration. Angular acceleration. So if the object is rotating, right, and it's rolling lah, at an angular acceleration of, now this one, right, it's actually alpha is equivalent to 33.76. So what is the relationship of alpha? Do you know? How do you convert alpha into linear acceleration? If you still remember, it's actually A is equal to R alpha. So the formula that you should use, gone already, to determine what is the acceleration of this wheel traveling, you should use this one. So radius dia berapa? 0.4 kali je lah dengan alpha kita, 33.76. Berapa jawapan? 0.4 times 33.76. You're gonna get 13.5 meter per second squared. Inilah acceleration of this wheel traveling, provided there is no slipping. No slipping. So if no slipping, it's very easy. You just settle this one and get alpha is equal to 33.76. Use this equation. This is A tangential, right? This equation has been developed before. Where does it come from? S is equal to R theta. V is equal to R omega. A is equal to R alpha. Coming from all this formula. Only works if the object is not slipping. So this is very important. If the wheel is not slipping, it travels properly. So use this one. No slipping. Tapi kalau dia slipping, dia pusing, tapi tak bergerak, then you have a problem already. Kalau dia pusing, tak bergerak, it is slipping, you have a big problem. You cannot deduce it immediately. Something like this. You have to use a different one. You have to look at the traction. Yeah, so you cannot use this one. If it is not slipping, like you are driving normal driving, right? You are driving normal driving. Yes, use this one. If it is slipping, then you have to look at something called traction. So, big word, but you've heard this word before. So you have to look at the traction lah. The forward moving force is this one, which is mu k times n. So you have to use this formula lah. Which formula you should use? Okay, the formula, the force that we are looking at is something called traction force. T-R-A-C-T-I-O-N, traction. So just use this formula lah. Summation of F is equal to MA. What are the forces going forward in this direction? There's only this one lah, which is this one. Mu k times normal. Okay is equal to MA. Mu k berapa? 0.5. Normal berapa? Dah dapat dekat sini. 196.2. 6.2. Mass berapa? 20 kilo. This is your A. A berapa dapat jawapan? Kali 0.5 times 196.2 bahagi 20. So you get 4.905. So this is a weird case lah. Most of the time don't use this. Why? You don't design your machine to be rotating at one place and slipping all the time. No. If you have a problem like that, you got to change it. You got to put more weight here. You don't want it to be slipping. So calculating this one is not my worry point. You have to use this one because most of the time our machines do not slip. So you can use this one immediately. If it slips only, you just use the traction force. Okay. Next, this one is almost similar. You've got some load here. What do we have here? This is a load. So this load has a weight. You've got tension. You've got, okay, read the question. 60 kilogram drum. Radius gyration 0.25 attached to a block having a mass of 20 kilo. There you go. Convert the drum's angular mass. You got this one by using radius of gyration, and then you have to use equation of motion. Summation of moment is equal to I alpha. Moment is coming from the tension of the cable. This one and alpha. And then summation of Fy is equal to MAY. This one is going down. So is it going down or up? This one, I don't like theirs. I prefer it. Yeah, you can use our convention lah. Going down is positive. You don't really have to follow the books. Use your own. Something that you have learned before. This one will become a positive. This one becomes a negative. This one becomes a positive. Yeah. Okay. So this one, you can do it on your own. Please do this on your own. And then check the answers. Next. This is a 30 kilogram disc starting from rest. What is the number of revolution it must make to attain an angular velocity of 20 radian per second? This is very, very interesting. And it's not so hard. Would you like to do this on your own? We have a couple more examples here. I guess let's do this one. Or do you want to do all? Okay, this is some tutorials that you should do. We'll start with this disc. Let's draw it. This is a disc. It's rotating at about here, point O. It already has a moment acting on it. What is the moment's value? 5 Newton meter. This is the moment. About point O lah. This is O. And it also has a couple of forces. One forces. 10 Newton here. So you have two things which is contributing to the rotation of this disc. Probably a pulley. It is asking us how many number of revolution it must make in order to get 20 radian per second. Okay. Is it so hard to do? Just use one formula. Summation of moment is equal to I alpha, obviously. So if it is a disk, we can use this formula lah to get moment inertia. Which is half mr squared. So half, mass dia berapa? 30 kilo. Radius berapa? 0.2 squared. Half mr squared. Dapat jawapan 0.6 kilogram meter squared. So I ni dah settle, alpha nak cari. So cari summation of moment. So since it's rotating this way, this is a positive. So you've got 5 plus 10 times 0.2 is equivalent to 0.6 alpha. So let's do this. Let's punch in your calculator. How much did you get? 5 plus 10 times 0.2. 2 is equal to 0.6 alpha. So you got 7 divided by 0.6. Dapatlah alpha. Berapa jawapan? 7 divided by 0.6. 11.67. 11.67 radian per second squared. This is the angular acceleration. How much revolution must it make to attain 20 radian per second? How much revolution? I think something like this. You can use the third formula. Omega squared is equal to omega naught squared plus 2 alpha theta minus theta naught. Use this formula. Why? There is no time. And you've got theta. So, in order to achieve 20, so this one becomes 20. 20 squared. Omega naught originally at rest. 2 times 11.67. How many revolution? So this one becomes 2 pi n lah. Because it wants revolution. If it wants theta, then can lah also. Because 361 revolution is equal to 2 pi. So let's do this. 20 squared is 400. So you're going to get 400 divided by you're going to get n. Let's solve this. 2 pi times 11.67 times 2. 284.8. 284.8. Did you get the answer? 400 divided by answer 1.40. So small lah. Is this correct? Have I squared everything? Doesn't seem right. Maybe this one. Maybe this one is wrong. Let's stick to theta first. Later we convert. Tapi betul lah kan? 2 pi times n. Kalau 20 rev 20 times 2 pi. Correct lah. I don't think I'm doing any mistakes. Let's try it again. 2 pi times n. Did I multiply wrongly? 2 times 11.67. Okay. Times 2 times pi. 146.6. 146.6. Is there any mistake? Determine the number of revolutions you must make to attain an angular velocity of 20 radian per second. 20 radian per second, originally at rest. Okay, 2. Alpha is 11.67. This formula comes from V squared is equal to V naught squared plus 2AS minus S naught. Betul lah. 400. Okay. Answer. 400 divided by answer. 2.73. Rotation. Correct ah? 2.73. Yeah, this is a problem ah. Calculator press error. Yeah, most of the time you gotta punch in twice in order to get the proper calculation. Yeah, that's good. What else is there? What are we looking at right now? Exercise 13. 100 kilogram cylinder rolls without slipping. So this is good. So without slipping. This is easy. Why? Cari alpha, and then you can deduce already from A tangential is equal to R alpha. Because this is no slipping. Whatever it rolls, it will translate to forward linear motion. So something like this is easy to calculate. Okay, so let's do this. 100 kilogram cylinder roll. 100 kilogram cylinder roll. Cylinder. Yeah, you gotta find the I. Cari dulu I. I sama dengan half mr squared. Half 100. Radius 0.3 squared. What is the value? 0.3 squared times 100 bahagi 2. You get yourself 4.5 kilogram meter squared. This is your moment inertia. This is the angular mass. What is the unit? Not kilogram, it's kilogram meter squared. This is how much moment it has to provide in order for it to begin rotating. Okay, what else have we got here? Yeah, we should be doing free body diagram. This is mg. This is normal. What else have we got here? This is normal. So it rolls without slipping. It's rotating this way. So it has something called traction. So this traction, we gotta give it a name. What kind of name should we give it? F traction. This is some sort of traction. Why is this traction here available? because it moves. If you don't have this traction force here, this thing will not be able to rotate lah and move. So it has traction. So how do we solve this? Summation of moment is equal to I alpha. Where should we take the moment? Probably here. Oh. What next? So you've got 200. Right. So summation of moment is equal to I alpha. How do we write this? It's kind of rotating this way. So let's take this direction as positive. So you got F is in this direction. It's rotating that way, so it's a negative lah. Let's say F times 0.3 and what else? Is there anything else at this axis? No, there's nothing else. So this one will be equivalent to I alpha. And this one is a negative. Why? Because it's rotating this way. So you've got negative 0.3 F is equivalent to 4.5 alpha. So this is your first equation. First equation. In order to solve this, you need one more equation lah. What kind of equation is that? Let's continue. In order to get it going, one more equation, which is summation of forces is equal to max. So to the right is positive. So you have 200 plus F. This one is equivalent to mass times acceleration. Mass times AX. So you got 200 plus F is equivalent to 100 AX. So, do you remember this one, which is without slipping? So without slipping, we can use A is equal to R alpha. So this one, we can substitute here. Now you're going to get 100 times radius berapa? 0.3 times alpha. So you have 200 plus F and this guy. So this one will become 30 kah? Let's arrange properly. This one will become 30 alpha. This one becomes 200 plus F. So this is your second equation. I guess if you want to use calculator, you gotta arrange it slightly more proper. Okay, let's use calculator. This one you gotta arrange it properly a bit. You're gonna get 30 alpha minus F is equal to 200. This is for your first equation. This is your first equation. Oh no, this is your second equation, okay? Second equation. Now look at your first equation, this one. Arrange it properly a bit. So that you can use your calculator. So alpha is in front, put alpha in front. 4.5 alpha plus 0.3 f is equivalent to 0. 0. So arrange it properly so that easy for you to press your calculator. This is equation number 1. So now grab your calculator. 30 alpha minus f is equal to 200. 4.5 plus 0.3. Okay, press your calculator. You're gonna get alpha s, how much? And f is equal to how much? So mode equation, one unknown, 30, negative 1, 200. 4.5, 0.3, 0. Solve it, you're gonna get 4.444. This one is for alpha. 4.44 radian per second squared. How about F? F is your tractive force, traction force. Negative 66.7 Newton. Check your answer. AG. Alpha is correct. 4.444. Okay, so yeah, you haven't solved this one yet, right? You need to know the acceleration. Acceleration is A is equal to R alpha. You want to know this object, the acceleration forward is how much? Acceleration. So you gotta plug in back here lah. Radius 0.3 times 4.44. Berapa jawapan? 0.3 times 4.44. 1.332. 1.33 meter per second squared. Same as the answer lah. So this is what you get. Again, you've got a couple more exercises here that you can do on your own. This one is great. This one is great. This one is great. Why? Why is this great? Because later on, when you're doing your final year project, you are going to be designing something called... What is this? These are called... Yeah, this is called robot arm. So when you design your robot arm, you are going to be using something called a motor. Over here. Motor. You're going to be using things like stepper motor, servo motor, servo motor. So something like this, the calculation is similar to this question. So don't come to me later on when you design your final year project. Your motor cannot rotate your arm. Cannot rotate. Why? There's not enough torque. Torque not enough. Why not enough? You do not calculate. You don't calculate it properly. So this is why we learn this chapter. You'll be using a lot of information from here in your final year projects. So some calculation like this, yeah, you need to really understand. Right. So this one, This is your IG, remember? Now you got to use parallel axis theorem and transfer the whole thing. This is your D. You got to get IO, which is equivalent to IG plus MD squared. Then you can use this in the formula of moment is equal to I alpha. Summation of moment is equal to I alpha. Then you'll be able to get what is this alpha rotation. So learn, you have to learn. Yeah, something like this is also very similar. Robotic arms, what else? Some sort of some sort of lever that you want to automate. Maybe you've got what this is your car. Okay, bad drawing. This is your MPV. MPV has this thing called tailgate. What a bad drawing. This is this tailgate. Okay, this is his bumper. What is this? Bumper. This is the MPV. Like that. Why you have a wheel here? This is a wheel here. This is the front door. This is the sliding door. This thing, you wanna put some sort of motor lever to open it up. Open it like that. Let's say you design something like this. So you wanna put a motor. Something like this, you need calculations like this. So you gotta remember mg is here, mg is going down here. So these are the places where you should go whenever you are in need of any calculation similar to this. This is the subject that you learn every single thing. Okay, so apparently we have come to the end of this, the end of an era, the end of engineering mechanics. So before we write the end, few things we need to remember. Remember. What? Don't read engineering mechanics. You need to do exercise. So once you've done your exercise, you need to get the highest level of mastery, which is the highest level of mastery is teaching others. If you can teach, you are the master of that particular subject. And if you want to be a better at knowledge, you have to be able to explain simply. Yeah, explain simply. Yeah, few things. This is very important lah. Do not read. Do exercise. And then teach others. Teach your friends. And explain it simply. If you cannot explain anything simply, you have not reached the level of mastery in terms of your knowledge. And I guess that's it. So see you next time. The end. Bye bye.